Welcome to this Wissens update. Look, if you write code, whether you're just starting out or you've been doing this for years, you know that managing your files can be a total nightmare. It's basically organized chaos. But when you throw artificial intelligence into the mix, oh man, the stakes get so much higher. So in this explainer, we're going to break down exactly how you can use Git, not just as a basic backup tool, but as your absolute ultimate control mechanism in the age of AI.
Seriously, we've all been there, right? You look at your project folder, and it's just packed with files named project_final, project_final_new, or my absolute personal favorite, project_reallyfinal_v2. We all do it, but let's be honest, this solo habit is fundamentally unsafe. The professional alternative is a clean, chronological Git history. Because in pro software development, you don't build your workflow around overwriting a single file over and over. Instead, you focus on a documented, clear timeline of changes. Which brings us to a pretty serious question. Have you ever actually lost your code by overwriting the wrong file? Or, and this is super relevant today, have you watched an AI coding assistant completely break your perfectly functioning project? Because it happens in seconds, literally seconds. An AI system decides to quietly swap out a core library while it's fixing a simple typo, or it refactors a dozen files at once. You absolutely have to have a reliable safety net. You need a way to see exactly what changed, and crucial point here, a way to step back if things go wrong.
So to make sure we don't get lost in the technical weeds, here is our roadmap. 1. The memory of software. 2. From code to commit. 3. Pull requests and teamwork. 4. Git in the AI era. And 5. Privacy and responsibility.
Section 1. The memory of software. Framing Git as foundational memory.
Okay, let's get our core definition straight. Yes, Git is a free, open-source version control system, but honestly, it's so much more than that. Think of it as the foundational memory of a project. It really isn't just a glorified save button. Instead, it meticulously documents your decisions, tracks changes, and captures your actual human intentions over time. When you use Git, you're building a system to answer what was changed, when was it changed, who changed it, and most importantly, why was it changed. In a world where AI might be writing the bulk of the code, having the system remember why it was written becomes incredibly vital.
Section 2. From code to commit. Mastering the routine.
So how do we actually build this project memory? Well, the path of a change in Git is a very deliberate three-step routine. First, you have the working directory. This is just your visible folder where you're actively typing code, deleting lines, fixing bugs, doing the actual work. But Git doesn't just automatically save every single typo you make. When you're ready, you move to step 2, the staging area. By using the command git add, you intentionally select which specific changes belong together. You're basically prepping them on a staging table. Finally, step 3 is the repository. Using git commit, you permanently document that selected bundle of changes right into your project's history. Now, this three-step routine is where the magic really happens, especially once we bring AI into the picture. There's a super clear dichotomy here. On one side, we have the what, the actual code being generated. And yeah, an AI assistant is incredibly fast at generating this what. But on the other side, we have the why. A commit is way more than just code. It includes a commit message. And it's entirely up to you, the human, to write that message and explain the intention behind the work. If you let an AI write the code and write the commit message without your input, well, you're losing the project's foundational memory. You're basically surrendering your own agency.
Section 3. Pull requests and teamwork. Safe collaboration.
Okay, so we've got the solo routine down. Now we need to look at the safety nets for professional teamwork. And the foundational tool here is the branch. A branch is, at its core, a completely safe experimental zone. Just imagine your project's main timeline as a sturdy tree trunk. A branch lets you step away from that main trunk to develop a new feature, maybe test out some wild AI-generated idea, or fix a bug, all without any fear whatsoever of breaking the main working project. It's honestly a psychological safety net just as much as a technical one. If the AI completely hallucinates and writes terrible code on your branch, doesn't matter. The main code remains totally untouched and secure.
Now, what's really interesting here is how we can completely reframe something that pretty much all beginners dread, the merge conflict. A merge conflict happens when Git just can't automatically blend two parallel branches together. Usually this is because two people, or a person and an AI, change the exact same line of code in different ways. When this happens, panic usually sets in. But Git isn't saying, hey, everything is broken. It's simply pausing and saying, hey, a human decision is needed right here. It's really just a communication tool. It's a signal that work is overlapping and you need to jump in and coordinate. And to actually make those human decisions, we rely on a concept called the diff. A diff is basically the ultimate visual reality check in software development. It shows you exactly, line by line, what was added in green, what was removed in red, or what was changed between two versions. Instead of forcing you to read through hundreds of files to figure out what happened, the diff focuses your attention right on the exact point of change. It filters out all the surrounding noise so you can see exactly what's going on.
Which brings us to a massively critical question you absolutely have to ask yourself constantly. Did the AI actually only change what you intended? Think about it. When you ask a coding agent to fix a simple button color, did it also quietly rewrite your entire security authentication in the background? You cannot just trust the AI's neat little summary. You literally have to read the diff. The diff does not lie. It is your absolute source of truth before you ever merge anything into your main project.
Section 4. Get in the AI era. Maintaining human agency. We are now entering the real boss battle of this explainer, managing coding agents without losing your project's integrity. So the crucial point is understanding exactly how you interact with AI. There's a dangerous way and there's a highly productive way. First, think of AI as an autopilot. This is where you blindly copy and paste Git commands, or even worse, you just let the AI automatically commit and push code for you without a single review. That's a total loss of understanding. Contrast that with using AI as a tutor. This is where you use AI to explain what a command like git status actually means, or ask it to translate a really messy merge conflict into plain English. You're still the one driving the car. The AI is just sitting in the passenger seat helping you read the map.
Section 5. Privacy and responsibility. Guardrails for your code.
Once you start mixing Git, artificial intelligence, and your actual project data, the real-world consequences get serious fast. So here are your non-negotiable guardrails. Number 1, no real passwords or API keys in your code, ever. Remember, Git's memory is permanent, and automated bots will scrape public repositories for leaked keys in seconds. Number 2, always check your diff before you execute a Git push. Pushing code is a public publishing step. Once it leaves your computer, you are accountable for it. Number 3, like we just talked about, use AI for explaining concepts, not just blindly copying solutions. And number 4, never ever feed sensitive project data, customer info, or internal secrets into external AI prompts. The convenience is absolutely not worth the massive security risk.
So, to wrap up our whole structured analysis today, AI definitely does not make Git obsolete. In fact, it's the exact opposite. Git makes AI safe. Because an AI can spit out thousands of lines of code in seconds, you need branches to contain it, you need diffs to review it, and you need pull requests to discuss it with your team. By mastering Git, you ensure that you remain the ultimate control mechanism over your project's history.
And I want to leave you with a final thought to ponder as you head back to your own code bases. If you allow an AI to write all your code, and then you rely on an AI to generate the commit message explaining that code, who is ultimately responsible when the entire system crashes? Right? The answer is you. Use the tools, leverage the AI for sure, but never outsource your understanding. Thank you so much for joining this Business Update. Keep your branches clean, always read those diffs, and I'll catch you in the next explainer.